adjust it. You are already there. We'll adjust it during the time.
Yes, sir. We can do that.
How much time is allotted for each speaker?
10 minutes.
10 minutes, sir. 10 minutes for each speaker.
Each speaker.
Because 15 speakers are there, 3 hours, and maybe one. After they finish the presentation, maybe 1 or 2 questions or any.
Okay.
Yes. Is all ready? Have all these speakers joined? Just please check it up.
I'm checking, ma'am.
Yeah.
Anyways,
Please check whether all.
Ask I have not received schedule of this technical session. I don't know where is my name.
Your name, please.
Shobha Rajmanya.
Shobha
Rajmanya.
You are not in this session anyways. No, I'll just check with the Shubha Rajmanya. Shubha Rajmanya.
Just before we start this session, I'll just follow the participants' name, the presenters. So if you're there, you please let us know. Harshita Shari.
Good afternoon, ma'am.
Good afternoon. Alka Rani. Then A. Bhagat.
Yes, good afternoon, madam.
Good afternoon. We are just checking who are all there so that, Esa Lohate. Bindu.
Good afternoon, ma'am.
Good afternoon. Preeti Jayaraman Shetty. Preeti.
Yes, ma'am. Good afternoon.
Ma'am, one small thing, ma'am. Sana,
yes.
you are in the other session actually. Sana.
Okay. Yes, good afternoon, ma'am.
Good afternoon. Okay.
You are in the other session.
Saki. Yeah. Raju Saki. Yes, Vasundhara. Yes, Vasundhara.
Yes, ma'am.
Okay. Sanya Agrawal. Kalaivani. Navajyoti. Tamuli. Abhiram Dash. S.V. Rajmanya. Sriman Narayana Gajula. Harsh Tripathi. Many are not there. Huh? Hisam, just find out maybe they have joined in the other session. Because just before we start, we can make sure.
Yes, ma'am. Actually, ma'am, Sana is not in this session, ma'am. She is in the other session.
Okay. Okay. Sana, you are in the other session. Okay.
Technical session 1.
Yeah, this is technical section 2 going on here.
This is technical session 2.
But why?
Can you just check your mail? You might have got a new mail.
Technical session 2 today or tomorrow?
Yeah, the technical session 2 is
today
going on.
We have parallel sessions. Technical session 1 and technical session 2. This is technical session 2.
Then technical session 2 today or tomorrow?
No, now only simultaneously.
Now only. You have.
Okay, I will check mail.
Yeah, you check your mail.
Okay. Thank you.
Madam, I am present. Shobha Rajmanya.
Okay, right. Yeah, we are just checking. So good afternoon to everyone. On behalf of the organizing committee, I welcome you all for the technical session of paper presentation. Today we have 15 speakers. For this session, we have Dr. Anil C. Matthew who will be chairing the session. So first I would like to just welcome sir for the
Thank you.
technical
Thank you.
session. Professor Anil C. Matthews is a professor of biostatistics from PSD Institute of Medical Sciences and Research, Coimbatore. And he started his career as assistant statistician in the Rheumatic Fever, Rheumatic Heart Disease Control Project of Indian Council of Medical Research at All India Heart Foundation, New Delhi in 1988. Afterwards, he joined PSD Institute of Medical Sciences and Research, Coimbatore as assistant professor in 1989, then as associate professor in 2003 and as professor in 2008. He's been actively engaged in teaching and research in applied biostatistics and for 3 decades, and he's reviewer and member of editorial committee of various national and international journals, which includes Indian Journal of Medical Research, American Journal of Epidemiology, and BMJ Online. He was an invited participant in the Indo-US workshop series on clinical research organized by US Embassy. And also he has been a statistical expert of the task force committee of the geriatric research in ICMR in 2011. And he has been organizing secretary of the annual conference of Indian Society of Medical Statistics. And he has been a visiting professor of biostatistics and epidemiology of Sultan Qaboos University, Sultanate of Oman in 2015. And also he was a member of Executive Council and Award Committee of ISMS 2017 to 19. And in recognition of the eminence achieved by the way of his outstanding contributions leading to the promotion of statistics in medicine, Professor Anil C. Matthews has been conferred on Fellowship in Medical Statistics of Indian Society for Medical Statistics for the year 2017. And Professor Anil C. Matthews has also visited several countries, which includes Bangladesh, Malaysia, Sri Lanka, Kuwait, Nepal, and other countries. We welcome you, sir. And I now request you to chair this technical session. Please, sir.
Thank you.
Please.
Good afternoon, sir. Anil, sir. Good afternoon, Anil, sir. This is Vishnuvardhan. How are you?
Thank you, sir. Thank you, sir.
Yeah. Please.
It's a great privilege for me to chair in this important workshop, and thank you for inviting me to chair this session. And I request congratulating all the speakers in the beginning itself for getting selected for presenting their papers in this conference. But I have only one small request with my experience. Usually they will spend a lot of time for the first 2 slides and no time for the last main results and discussions. Should not happen. Even if you skip the first 2 slides, give more emphasis for your results and the discussion part. This is only a small suggestion from my side only. Let us welcome all the speakers. And let us start the meeting with Harshita Chari. It's a religious topic. She's addressing it. Let us and please introduce yourself. Where you are coming. Just introduce about yourself, and then you start presentation.
Good afternoon, sir. Good afternoon, ma'am. I'm Harshita Chari, and I have done my MSc Statistics in Pondicherry University itself. And now I'm doing my MPhil in Population Studies from International Institute for Population Sciences. I will be sharing my slide now. If there is any issue with the sharing of the screen, please do inform once.
Yeah.
Is my screen visible?
Yes, visible. Slideshow, you keep it. Slideshow.
Yes, sir. It's in slideshow only.
Okay. It's fine.
Yes, sir. Good afternoon, everyone. My topic today is understanding spirituality, religiosity, and well-being. It is a study across various dominant religions. I have done this study, this paper along with my guide, Dr. K.C. Das from IIPS only. So before beginning with this thing, I first would like to just give one line introduction for religion, what is religion and what is spirituality. So religion is basically an institutionalized system of religious beliefs, attitudes, and practices, whereas spirituality is an experience of connection that is something larger than you. It is more within the soul. So as I said that I too would not want to waste much time on the introduction, but just a small first slide that from the very in our ancient cultures we have that the care for the body and soul has been always integrated. There was no difference in that, but nowadays there has been a separation due to which the religion is seen for more of the spiritual needs and physicians are seen as the physical one, which is not always true. In the 37th World Health Assembly, WHO had asked all the member states to include a spiritual dimension in their health for all strategies. As the spiritual dimension plays a great role in motivating people's achievements in all aspects of their life. These are some literature review which I have put on, which give the positive relationship between the religious participation and the health criteria, which include psychological distress, better health-related quality of life, the decreased morbidity and mortality in people. Here I have taken the data source which I have taken basically is the sixth wave of World Values Survey, which is a multi-country representative survey conducted during 2010 to 14. This was the sixth wave done. And WVS is basically a global network of social scientists that study the changing values and their impact on social and political life. The data was collected using PPS sampling and from the voting precincts in all of the countries which have been taken, and the age group, the population included were in the age group 18 years and above. The countries which have been included in my study, I have basically taken six countries: India, USA, Romania, Iran, Brazil, and Thailand. And the religions which I have included majorly are Christianity, Islam, Hinduism, Buddhism, and the people who follow no religion. The dependent variables which I have included are self-rated health, which is when a person tells how they really feel about themselves, and it has three categories: good, fair, and poor. The feeling of happiness, happy, quite happy, and not happy, and the satisfaction with life, satisfied, somewhat satisfied, and dissatisfied. These three are the data which we have taken from the people, and I have included as dependent variables. Now, as you can see, the response variables are ordered variables with three categories, and hence I have used multinomial logistic regression to examine the effects. My independent variables which I have taken here, they had to be very careful. I had to be very careful in choosing the religious and the spiritual variables which I have taken, because as we all know, as statisticians, we see them as very abstract concepts, but still I have tried to make them work. The first one was importance of religion in life, which in Likert scale, it was very important, rather important and not important. Importance of God in life, thinking about meaning and purpose of life, which second and the third one are basically more towards spirituality. The fourth is frequency of attending religious services, and the fifth was frequency of praying. So now I'll go on to the results. These two are the first graph that I have taken. I have done very basic statistical analysis in the beginning, which give the importance of religion in life. So as we can see, religion is felt to be very important in the countries of India and Iraq, which you can see in the first graph, and then among the religions, it is felt to be important in Muslims, Hindus, and the people who follow other religions. Religion is not felt to be important by a lot of high percentage of people from the USA and the people who follow no religion, which is very obvious. The next is importance of God in life. So as we can see, God is seen to be very important in life in countries like Romania, Brazil, and Iraq, which and the religions which are Muslim, Christianity, and Hinduism. And religion is God is not seen to be important in Thailand, and with along with Buddhism as a along with the religion Buddhism, which don't feel God is important in their life, and also the people who follow no religion. The third one is thinking about meaning and purpose in life. So when we see that we see the frequency of how much people think about what the meaning and the purpose of their life is. The first one is we see Romania and Brazil feel they think a lot about their meaning and purpose in life, and also Christianity and Buddhism. These two religions think a lot more. You can see Hinduism has a very low percentage in the people who often think about it, and the people and the percentage there is a very less percentage of people who never think about meaning and purpose in life. The fourth one is frequency of attending religious services. As you can see here, the people who uh, attend religious services more than once a week are from the countries Brazil, India, and Iraq. And similarly, in religion, it is Hinduism, Christianity, and Muslims. And the people who never attend religious services are in USA. The highest percentage is in USA. And when we see in religion, it is the people who follow no religion. It is around 78%. The next one is frequency of praying. As you can see, the people who pray several times a day, the percentage is high in the countries of Brazil, Iraq, and Romania, and it is high in the people who follow Islam, Christianity, and Hinduism. And the people who never pray, practically they never pray, are more in USA and Thailand. And similarly, the percentage is more in the people who follow no religion. Next, I have come to the results which I have got from multinomial logistic. And first one is effect on the self-rated health. I have done multinomial logistic with these 5 independent variables on the 3 variables separately. So on self-rated health, the base outcome I have taken is good. And as the results which I have come across, which are I think important in my viewpoint, is as the importance of God in life decreases, the odds of having fair health with respect to good health also decreases, and the odds of having poor health increase with the decrease in frequency of thinking about meaning and purpose of life and the frequency of attending religious services. The next is the effect.
Some network problems.
Arshita? Arshita?
Hello?
Harshida,
Harshita.
last 2 slides we are not able to see it. Can you just show it to me once again?
Yes, I'll share.
Yeah,
Sorry, sir.
some technical issues.
Okay, sir.
Okay.
So are the slides visible now?
Yeah, now it's visible.
So
Yes.
is this the slide or the next one?
Next. This was, this one, yeah.
Okay. So in effect on self-rated health, as I've said, I do the multinomial logistic regression between the self-rated health and the different religion spiritual variables, and the base outcome is taken to be good. So the results which I find important here are is that the importance of God as the importance of God in life decreases, the odds of having fair health with respect to good health also decreases, and the odds of having poor health increase with the decrease in frequency of thinking about meaning and purpose of life and of attending religious services. The next one is effect on level of happiness. The base outcome here I have taken as quite happy, and we see that the odds of people being not happy decreases as the importance of God in life also decreases, which is a little bit a weird concept. And the next one is the same the odds of being not happy increases with a decrease in frequency of thinking about meaning and purpose in life. The third one was effect on satisfaction with life. The base outcome here I have taken as satisfied. The odds of being not satisfied decreases with a decrease in importance of religion or God in life. There is an increase in being not satisfied with a decrease in frequency of thinking about meaning and purpose in life. And there is an increase in being dissatisfied with a decrease in frequency of attending religious services. So I'll come to the conclusion now. As we can see, there is a positive relation between religion and spiritual variables with the self-rated health, level of happiness, and the satisfaction with life. The people who, in my results, I have seen that the people who are non-believers are seem to be more happier and more satisfied in life in comparison to the people who identify themselves with a religion but don't follow the customs accordingly. Like they don't, the frequency of their praying or the frequency of their attending religious services is very low, is midway. They rarely think about them, and they are less satisfied and less happier than people who follow no religion at all. What I understand from this is that following God can help you achieve mental peace only when you surrender yourself fully and trust the divine process rather than doubting it a lot. A person who believes in hard work and their own karma can also lead a better and peaceful life than a person whose belief is half-hearted. So whatever you do, you have to have a total belief in the process. Otherwise, it is much better to not have arguments. Like, it is very difficult to be a very religious person and along with it have logic, explain the religious outcomes that we have, because most of the religious outcomes are also negative nowadays. There can be a lot of further study which can be done, because this paper which I've done is my work of, I think, 2 to 3 weeks. So there can be a lot of further studies. So I can take the data for all the countries which have been in the survey and do have a greater sample. The socio-demographic variables which I have missed out in this can also be added to have a much more better understanding according to people's sex or the people's age and the country where they are from. I can also create some indexes which can be used for comparison and further analysis. Like, there can be index on spirituality or happiness of the people, and we can compare across countries. Thank you. This was my very brief presentation.
Very
I'll
good
stop sharing.
presentation, Shida. Very, because you finished the correct time and very clarity of the slides. I congratulate you. I have only
Thank
two.
you.
So how far is the quality of this data? How can we trust the quality of the data, the source of the data which we have used? How far we can trust on it?
Okay, sir.
Like,
Sir, this question was very.
a country like India, this much of people are praying. How can we trust that data?
So to be honest, nowadays we can't trust a lot of data. They all are sample surveys. There can be a lot of talks about the validity and reliability. But the thing because I followed this data was this data had the eighth round of the data is now going on, the collection of data. So I think there should be some reliability and validity of it. That is why it has been continued for a long time. And they collect data over around 130 or 140 countries. So even though the like in NFHS that we have in India, we have around 6 lakh samples because it is only done in our country. But when we see a world value survey, the sample gets lower. But we have to find a way to understand it in a much better way or in a big concept, I think.
Second question. What made you to choose multinomial logistic regression over ordinal logistic regression?
Because I had 3 categories in all. I had usually 5 categories, which I combined them to make 3 categories. And I felt multinomial would be a better way to help me understand, because I did ordinal, but I was not very much happy with the results that I got. So they were very bland results. So I took multinomial logistic again.
Thank you.
And they suited the concept.
Best wishes. Best wishes.
Thank you. Thank you so much, sir.
Next presentation is Alka Rani.
Excuse me, sir. Sir, just 1 minute, sir.
Yeah.
Sunanda Wang, your session is not this one. Can you just join in the other session?
No, sir. Sir, I am present, Dr. Mrs. Sunanda Wag.
Your session is in the other one. Yours is not this session. This is session 2, technical session 2. You are supposed to.
This is section 2. Okay, sir. Okay, sir.
Please check your mail, ma'am.
Okay.
So now Alka Rani.
Present, sir.
Yeah.
Very good afternoon to all of you. I'm presenting my screen now.
Yeah. But your face is not visible. Yeah. Alka Rani, what happened? What happened?
You can go to present now, then share entire screen or window.
Hello.
Yes.
Yes.
Yeah, you can present.
Are you able to see my screen?
No,
Not able to see it.
not able.
Yeah.
Now?
Opening only.
Hello?
Yeah, we can see the abstract. Yeah. Okay, you
Okay.
can present.
My paper title is Various If Measures and Relations to Select Suitable Land for Rabi Crops. Agriculture has always been the backbone of Indian economy. In our country, more than 60% population earns its livelihood from agriculture. It fulfills the basic need of human beings as well as animals. The geographical condition of our country is solitary for agriculture. It provides various conditions. But many irrigation and good extension services are among the factors responsible. To overcome this problem, we suggest some methods to select suitable land for various crops. We apply the concept of instinctive fuzzy measures and relations. For this choice, we propose a hypothetical data containing information about land, factors affecting, and some crops with assigned degree of membership, non-membership, and hesitation index. India is the largest democracy of the world. Agriculture is a major sector of our economy. India's growth product and impressive growth, plenty and power, but current agricultural conditions are methods, population erosion, information heard by farmers, various issues in agriculture. There are low methods which can select suitable land in comparison of the production. We apply maximum composition. That we are to the solution. Agriculture. Can I have amend an activity? Since it all has various decision-making problems. About Rabi crops. Crops are the plants of same type or origin that are grown on a large scale at a place. Each crop requires specific climate for proper growth. Crops are Rabi and monsoon or Kharif. Winter season affected by rainfall. In wheat, gram, oat, barley, potato, mustard, and sunflower, and etc. Research methodology and procedure to guide. To find the solution, explanatory type system is to find out we are also pattern the cultivar crop. In order to find the we put some factors. First step, we establish relation between the factors of crop, find the and known members value. Secondly, we establish the between some Rabi crops with a known value. Then we apply our methods maximum composition and we for evaluation. Next step, we find the value of hesitation. Finally, we apply Rene Kapoor if failure. The maximum weight for each land has been taken. If there is a tie in weight values, that means that land area may be suitable for both types of Rabi crops. About fuzzy logic and instrumentistic fuzzy sets. Instrumentistic fuzzy theory is constitute an extension of fuzzy set theory. There lie membership degree, non-membership degree, and hesitation. In IIS, the hesitation is incorporated. If the value of hesitation is 0, it means IFS theory becomes fuzzy set. Today, describe the agricultural theory. Have done a district-wise for showing the performance of Indian agriculture.
Madam, only five more minutes. Important results, can you tell it? Because
okay.
Full paper you may not be able to read in a conference.
Okay, sir.
Important findings, you have to summarize it in 10 minutes and 10 slides. We would have expected. The full paper as such it is presenting is not correct actually. You can tell the important findings, madam.
Okay, sir. Actually, there. Sir, मेरी वो PPT is open नहीं हो पा रही थी. That's why I have to open the paper now. Now, two fuzzy relations Q and R are defined as composition of T or I and Q. Then we identify land area more suitable for the crop. We apply both methods, Rene entropy and Kapoor entropy. Here mu I denotes the degree of membership, Vi degree of non-membership, and pi I denotes the hesitation index. At last, from Q and R, we have applied a new measure of IFRT, for which in general the analysis step of land area for any crop C such that following is to be satisfied. This is Rene entropy, and second one is Kapoor's entropy. After that, third is Rene T is equal to R composition Q is retained application. Let हम 5 lines L1, L2, L3, L4, L5 with a set of 5 different areas, and F are the factors affecting the crop yield. Here, F, U, Q, V are the of membership degree and non-membership degree. Where now C is the factors. C crops, wheat, chickpea, barley, mustard, oats. We are selecting Rabi crops, and here are the compositions about land and crops. Now we apply the maximum, minimum, and maximum composition on table 1.1 and table 1.2. In case of membership degree UQ, we take maximum of the minimum value, and in case of VQ, we take minimum of the maximum value. After that, we find out T, the composition of R and Q, and from this we make table 1.4 in the value for this set. Now later on the values of these 1, 3 and in the solution we can of alpha which is greater than 0. In case of if measure, here we take the value Rene entropy for different values of alpha. Results are alpha is equal to 0.1, then the take alpha equal to 0.2, then results become these. For alpha 0.0.3, 0.4, 0.5, 0.6, 7, 8, and 9. For different values of alpha, we find different solutions. From the table, we can see the crop 1, the land 2 and L4, Yasi and Hisara moves the production of land are more suitable. Mahendragarh district is more suitable for the now like on table 1. And result. For 1.1, 1.2, Here concluded again results about and entropy. Conclusion in this comparison having explained about how the gives the same results and used an can also be used. These types of methods may be effective in problems, mainly of particular diseases. These are some references. Thank you.
Sound.
Hello.
Yeah. You can continue.
Hello.
Yes.
Hello.
Yes.
Is there any question?
I can see it.
Sir, Anil sir.
Yes.
Sir, we will ask the presenters to just present for 10 minutes. Stick to the time, I think.
Yeah, that's what I'm shocked of.
Yes, sir. Yes. Yes, sir.
It's a conference, international conference. They should have kept with the 10 slides.
And all the participants are requested to keep your presentations ready. Okay.
Only
After we
slides.
announce your main name, please don't search and do it. Keep your presentations ready.
And only 10 slides, maximum 10 minutes. One slide for 1 minute. That is the way which you have prepared it.
Yes, sir.
Anyway, thank you, madam. Thank you, madam. And any discussion? You have anything? Anybody to contribute anything? Please.
You can stop.
Shall we go?
Yeah, yes, sir. Yes, sir. You can stop sharing, Alka.
Yeah.
Please, you can.
Thank you, ma'am.
Thank you.
And sorry for actually, ma'am. So that, ma'am.
Next, Anju, are you ready?
Yes, sir. Yes, madam.
Yeah.
Yes.
Yeah.
क्लिक करू का? Hello, madam.
Yes.
Hello. Anju Bhagat speaking, ma'am.
Yes.
She is not stop her sharing, na?
Alka?
Yes, ma'am.
Please, you stop sharing. The next speaker has to share her presentation. You first stop sharing. Yeah. Sir, I think you can just.
Okay, ma'am. I am sharing my presentation, madam.
Yeah, just wait, sir. We'll just. Sir, you can just go next.
Yeah.
Yeah, because since the name is not there, I'm just pressing. But you can start presenting. Introduce yourself and start presenting.
Yeah.
Anshu, introduce yourself and start presenting.
Yes, sir. Select screen. Hello. Huh?
इंटर स्क्रीन टच कर इथं मी खालचे इंटर खाली त्याला त्याला
Hello. Hello. Good. Yes, no?
Just share your presentation.
Yes. Yes, yes. Is it visible, madam?
No, no. Yeah, now it's just loading it. Yeah, yes, yeah.
Is it visible, madam?
Is it visible? It's visible. It's visible.
Okay, madam. Okay, thank you, madam. I am Dr. Mrs. A. Bhagat, Assistant Professor of Statistics. I am belongs from Mahatma Phule Krishi Vidyapit Rahuri, and presently I am working at Zonal Agricultural Research Station Pune. My research topic is trend and variability of rainfall in Jalgaon district of Maharashtra. Was to study the rainfall trend and variability in weather parameters of Jalgaon district. For that objective, I have collected the secondary data on rainfall and weather parameters. That data was collected from the Oilseeds Research Station Jalgaon from the year 1991 to 2018 for the total 28 years. Then in introduction, see here, as we know that the rainfall is the most important weather factor that determines the agricultural production, and presently there is a large amount of variability in rainfall and also the weather parameters. The farmers are facing major problems in getting remunerative yield of crops. The adverse climatic situation and persistent changes in area production and productivity of different crops in Jalgaon district. For that purpose, I have taken this study in order to study the trend of rainfall and variability in weather parameters in the Jalgaon district. For that purpose, I have used here the man candle rank non-parametric test to see the trend in rainfall. Then also I have used here the arithmetic mean, standard deviation and coefficient of variation. Then this is the first result table for the man-Kendall rank test for monthly and seasonal rainfall in Jalgaon district from 1991 to 2018. Here the man-Kendall tau statistics, some values are positive and some values are negative. Positive value indicates that there is an increasing trend in rainfall, and the negative value indicates that there is a decreasing rainfall in that particular month or season. Here it is observed that the non-significant increasing trend was observed during July, August, September, and February month. And however, in pre-monsoon season, here I observed that the significant declined rainfall in Jalgaon district during the study period from 1991 to 2018. And also for other seasons and other months, observed that there is a declining trend in rainfall. Then this is the actual graph of trend of rainfall in Jalgaon district. And here we can see that the trend of overall rainfall is decreasing gradually year wise, means 1991. Only 1 year in 2006 there is a very high rainfall received in that particular year, that is near about 1400. Then this is the second table of result. Here I have considered the only monsoon data. Monsoon period data means I have considered July to September data. And here in this table, the average maximum temperature was 33.4 with the 2.4 coefficient of variation. And here the mean average minimum temperature was 23.8 with the coefficient of variation 5%. The average relative humidity at morning was 80.9 with coefficient of variation was 6.2. The average relative humidity at evening was 60.8 with coefficient of variation 10.2. The average wind velocity was 6.6 with coefficient of variation 43.9. The average evaporation was 5.6 with coefficient of variation 25. The average bright sunshine hour was 7.7 with coefficient of variation 58.4, and the average rainfall in mm from 1991 to 2018, that was 676.3 with the coefficient of variation 30.4, and the number of rainy days was received during the study period was 40 with the coefficient of variation 22.5. Then among the weather parameters here, the bright sunshine hours was recorded the maximum coefficient of variation, that was 58.4, followed by the wind velocity, that was 43.9. My two conclusions. The first one conclusion is the mean annual rainfall in Jalgaon district showed a long-term insignificant decline trend except the pre-monsoon season, because during the pre-monsoon season we have observed that the significant decline trend in rainfall during the study period, and the average rainfall was 676.3 mm with rainfall variability was 30.40 centimeter. The second conclusion was among the weather parameters, high variability was observed in by bright sunshine hours, that was 58.4%, followed by the wind velocity, that was 43.9% in Jalgaon district during the study period.
Any questions from the participants? Any questions? But I have only one question. The standard deviation is very high in one of the table. Then I don't have much expertise in this particular topic which you are presenting. But still, with the simple knowledge, when the standard deviation is so high, how can we rely on the mean value? You have anything to add, madam?
Sir, standard deviation gives us the variation in a data. Okay.
Yeah,
because
215 in one of the table which you are mentioning, but the mean value is 600 or something like that. So when standard deviation is so high, I just asking you your opinion on the relay. How can we trust the mean value? That's my question.
Sir, data is a realistic data, sir. I have collected, actually that the data is collected from the meteorological observatory. The data is accurate, sir, no problem. And also real data. I have taken the real data from that research station. There is a one meteorological observatory is fitted in the field. Then I have collected the data from that research station. Data, sir, I have observed such a type of results after fitting the standard deviation.
Okay, madam. Good. Thank you. Thank you, madam.
Okay, thank you, sir.
Next presentation. Who is going to present the next?
Stop presentation.
And next is SR Lohate. Is there? SR Lohate? Lohate. Yes, the list it is. Next is Bindu. Bindu.
Yes, ma'am.
Bindu, are you there?
Yeah.
Yeah, then okay.
I will share my screen.
So,
Afternoon. Can you see my screen?
yeah, Bindu, just introduce yourself, then you start.
Myself, Dr. Bindu PP, Assistant Professor, Department of Statistics, Government Arts and Science College, Calicut. Today, I am going to present my research by DST Sir, Government of India. The topic of my presentation is identification and ranking of differentially expressed genes in microarray studies. First of all, I would like to give a brief introduction regarding what is microarray technology. Actually, microarray technology is one of the powerful tools to study the expression levels of thousands of genes, and it is one of the fundamental tool for comparing the expression levels of genes under diseased and test situation. And this is actually the structure of the microarray experiment. Due to the time limitation, I can't explain regarding the background of this. And in microarray, we have studying the expression levels of thousands of genes in parallel. It is a high throughput technique. And after the experiment, the biologist upload the expression. Actually, the expression levels, actually the images out of the microarray experiment, and using with the help of the program, they will convert the numerical value. Actually, we have two color intensity data, red for the test population and green for the control. And numerical values are uploaded in the site. And I have downloaded the data from the Stanford microarray database. And here is the format of the data. Matrix form, and here the rows represent the expression levels for the specific gene, and columns represent the replications, or maybe sometimes it is the measurements taken at different time points, or sometimes it is the replication for this measurements for each gene. And also, one of the approach is studying the distribution of error distribution of microarray data. Actually, the error distribution is the log ratio of red and green intensity data, and there are a lot of work done by various researchers. And from their research, we can see that the error distribution is asymmetric and have heavier tails, because in microarray gene expression data, majority of the genes are not differentially expressed. Only few are differentially expressed. So the data is skewed and heavy-tailed. Myself and several other authors studied various models the error distribution. In this study, I have developed a multiple hypothesis testing procedure, because in microarray, we are interested in studying whether a particular gene is differentially expressed across different disease conditions or different exposures or something like that. Depending on the study, it's vary. And here I am considering that problem as a multiple hypothesis testing problem. Each hypothesis actually tests whether that particular gene is differentially expressed. And we cannot use the usual classical testing procedure, because here the number of genes are very large, and maybe more than 20,000 genes, and replications are very few. So there is a possibility of false discovery rate or type 1 error. So I used the technique introduced by Benjamin and Hochberg in 1995. Introduced the concept of false discovery rate, and it has applications in many genetics studies. I'm not going through all this. We have only limited time. Actually, the FTR is actually defined as the expected value, the ratio of total number of incorrectly rejected hypotheses to the total number of correctly rejected hypotheses. And in this case, we can see that we have several, the number of hypotheses is very large. And so because of that, the power of the usual testing procedure will be very low. So I have used the technique of generalized p-value approach, generalized testing procedure introduced by Veerahardy. Also, I am also modified that testing procedure using the empirical based approach introduced by Efron and Smith. And also I have identified the most significant gene, and also I have ranked the gene also using the mixed Laplace approach also. And I am not going to the theory of generalized p-value approach, and you may refer to Sui and Veerahardy 1989 and 1993 papers to get the introduction of to get the details how we can form the generalized pivotal quantity and what are the procedure of this testing. And here I have used also incorporate in generalized test statistic. I also incorporated additional some information with, using the empirical base estimate for the variance by giving prior information for the variance parameter. I consider the variance parameter as a random variable, and also so to improve the testing procedure, I have incorporated the Bayesian approach also, empirical Bayesian approach, and also calculated the posterior variance and all these things. And here I have, we have in this situation, we have two populations. One is the test population, the other one the control population. Here the observations, this data is I have collected from the Stanford microarray data. And here the observations are like this. I represented the data as Xij, where the first suffix represent I represent whether it's from the 1 represent for the test population, and 2 represent the control population, and J, the suffix J represent the gene, sorry, the replications, and G represents the genes. I have two sets of data, and for each gene, and also we have the replications for. And also I have given the distribution, fitted a distribution for this using shifted exponential, because the log ratio usually follow the asymmetric Laplace distribution. Here, so each asymmetric Laplace distribution actually difference of the exponential. So difference of exponential with the different scale parameters. So because of that, I have considered that these two population follow shifted exponential distribution, and I have developed a generalized testing procedure based on that. And also I have computed the estimate for the parameters for the two data set, test and control data set. The N1 represents the number of observations in the first group, that is the test, and N2 represent the observations in the second. Actually here N1 and N2 are equal. And I have developed a generalized test pivotal quantity using the theory of Virahandi. And also in this I have replaced the sigma gi, that is the variance of the gene, particular variability of particular gene. And also I have replaced that instead of giving the actual variance, I have given the considered that as a random variable, and then substituted the posterior using the empirical base approach. And this is the testing, generalized testing procedure. And here the problem is to test whether the particular gene is differentially expressed or not. And then we can write this problem as h0 mu1 equal to mu2 versus mu1 not equal to mu2. And based on the theory developed by Virahandi, this is the test criterion. And I have computed this test values Tg, and also probability of Tg less than or equal to 0, and probability of Tg greater than 0 using an algorithm. We have developed an algorithm in our package. From this we can compute these probabilities by calculating the proportion of values for which the Tg is less than 0, and we are using an algorithm I have computed, and then take the minimum value and multiplied by 2. And also I have incorporated the this FDR approach. I have computed the p-values for each hypothesis, and then I have used the FDR approach by fixing a false discovery rate to a particular value, and then I have estimated the false discovery rate for each gene for a particular PI values. I have computed the PI values, and then I have estimated the false discovery rate for each gene using the equation number 8. And I have used the data set for illustration purpose. I have used the breast cancer data set of Van Geer et al. In 2002, and we have we have 295 samples from patients with primary breast cancer, and I have using the algorithm developed in our package, and I have compared the modified generalized p-value test using the usual t-test and computed the estimated false discovery rate, and we have in gene expression studies, we have differentially expressed means some of the genes may be overexpressed or some may be underexpressed. So depending on this value of the test statistic, I have classified that as under and overexpressed, and I have fixed the false discovery rate to a particular value, and I have identified up to 100 out of 24,479 genes. I have chosen only 100 genes which are differentially expressed. And from this table value, we can see that the generalized p-value technique, modified generalized p-value technique, identify the more genes with the less false discovery rate. For generalized p-value technique, this false discovery rate is very less. And next, from the 100 differentially expressed genes, then I have used the procedure incorporated by used by McLachlan in 2006. He used the compound Gaussian model for identifying, classifying the differentially expressed genes, and here I used the Laplace compound Laplace. Mixed Laplace model, because Laplace distribution is more suitable for this kind of microarray data, because Laplace has a sharp peak in the middle, and so I have developed a testing procedure following the steps by McLachlan, and I have ranked the differentially expressed genes. Actually, I have taken the 50 genes, and here I have tabulated only 10 genes which are differentially expressed, most depending on their FDR value, false discovery rate value. I have listed these genes from that data, and from in this paper, I have studied, introduced modified generalized p-value approach for dealing with the multiple hypothesis testing problem in microarray gene expression data, to identify the differentially expressed gene and to rank the genes according to their expression values, according to their significance. And this may help us to identify, to find the relationship between the association of genes with the disease. And these two approach the FDR by Benjamini and Hochberg and generalized p-value, both are a very powerful technique. And in this study, I have modified the techniques introduced by them, and I have got differentially ranked the most significant differentially expressed genes.
Thank you.
These are the reference. Thank you.
It's a good area of research. You are doing is a part of PhD research or something?
No, sir. It is a part of my major research project under DST SERB.
Any guide?
My PhD is actually on microarray statistical applications in microarray technology and bioinformatics.
Who's your guide?
It's on St. Thomas College.
Guide.
Sir, you know me also. I have presented several times under your you chair, SS chair. Yeah.
Dr.
You know me.
Dr. Binu in Manipal. Now he's the.
Yeah, he also did PhD under the same topic.
Yes, he has done the same work. I think once I was.
Kumaran sir is one of my thesis evaluator.
Okay. Anyway, good presentation. Best wishes. Yeah?
Yes, here is very lot, and I try to reduce the. And I don't know whether it is.
But it's a good presentation, madam. Good presentation.
Thank you, sir. Thank you, sir.
Okay. Next to whom we should call Preeti.
Yeah. Yes. Yes, sir. Preeti.
Yeah, Preeti.
Hello, sir. Myself Preeti Jairam Shetty, and I am working in Mangalore University, Karnataka. Now I am presenting my screen. Whether screen is visible? Whether screen is visible?
Visible.
Okay, sir. Thank you. So my research paper is on statistical innovation and strategies for air pollution challenges. We all know air pollution is continuously causing major damage to the earth environment. It will also severely affect ecosystem and disturb ecological balance. Around the world, 9 out of 10 people breathe unhealthy air. Air pollution is serious problem and most people are still unaware of air pollution cause and its effect. Delhi was the world's most polluted capital city for the second straight year 2019, and Delhi is the fifth most polluted city in the world. So according to Central Pollution Control Board, air quality standards are categorized like this, and air quality index in Delhi stood in very poor category, were recorded at 313 today. So these air pollution challenges are not only causing trouble to human beings but also cause animals and plants. Hence, appropriate measure must be taken to tackle this hazard. Air quality index is the tool for identifying the severity of the pollution. The major air pollutants are bad ozone, particulate matter that is in 2.5 micrometer and also 10 micrometer, then carbon monoxide, sulfur dioxide and nitrogen dioxide. The higher the air quality index, increase the health risk as well. From the literature review, we observe that most of the research paper focusing on handling violation of basic ideal conditions separately. But in this research paper, pollutant variable shows both autocorrelation, that means variable are changed according to time, and multicollinearity, that means variable reacting with each other. Therefore, researcher need to focus the tackle on this problem simultaneously. About data, it is known that almost entire city of Delhi is enveloped by pollution layer all around, with the contribution of from multiple sources within the city, nearby region and even from the long distance. In the broader sense, the air is more toxic as it contains larger contribution of combustion product. The level of PM particle and CO are statistically higher. Therefore, in this research paper, we focusing on identification and estimation of influence factor of air quality index of Delhi and forecasting the future of air quality index and its significant risk factor. The data set was collected from website of Central Pollution Control Board of India, and we consider these variables. So in the methodology, the main objective of the study is to identify and estimation of air quality index, also forecasting air quality index and their significant variables. That is why I applied regression, also time series techniques. So in regression, parametric regression and non-parametric regression techniques are applied. So in this data, there is a situation called regressors are correlated and error terms are autocorrelated. This situation is called as there is a autocorrelation in the presence of multicollinearity. At that time, we use ridge regression by neglecting autocorrelation, and we use autocorrelation by neglecting ridge regression. Also, we use generalized ridge regression, ridge type estimator. That means combination of those ridge regression and autocorrelation. So to forecast air quality index and their significant risk factor, we use traditional time series, also artificial neural network method. So this table 1 represents the significant regressors of air quality index. You can see here, except benzene and nitrogen dioxide, all the other variables are significant, and this CO has positive effect. Also PM 2.5 have positive effect on air quality index, has larger impact on air quality index. Therefore, according to R square, we can say 94% variation in air quality index can be explained by these regressors. So I already said that in this paper, I compare parametric and non-parametric regression. According to that result, we get generalized read type estimator is the best method for predicting the air quality index based on this RMSE value. So here multicollinearity is considered, and at that time, while handling the multicollinearity, we neglect the autocorrelation. While handling the autocorrelation, we neglect the multicollinearity. And generalized read type estimator means combination of these multicollinearity and autocorrelation. Here we use generalized least square for autocorrelation, because autocorrelation is a particular case of heteroscedasticity. So in this one, we get generalized read type estimator is the best estimator. Comparing the original value with the predicted value from generalized read type method. So these are the original value and this value from generalized read type estimator method. So next, time series. So here, first I consider air quality index variable. From time profile, you can see there is a variation, there is a seasonality in the data. So from rank sum test, we get there is a seasonality in the data. From man candle test, we get there is no trend in the data. By removing seasonality, by carrying out the seasonal difference, we make that series stationary, and we get capital D is equal to 1 and trend difference is equal to 0. From ACF and PACF plot, we observe that this non-seasonal and seasonal orders for MA and AR model, that is capital Q equal to 1 and small q equal to 1, capital P equal to 2 and small p equal to 2. We fitted Sarima model based on different combination of PDQ, also small PDQ, based on minimum AIC value and maximum P value. This Sarima 001110 is the best model. And these are the forecasted diagram of air quality index variable from traditional time series method and neural network method. So according to accuracy measure, we can say ELM has less RMSE, MAE and MAPE value. Therefore, this ELM is the best method for forecasting air quality index. So using that method, we forecast for the next 2 years. And from the forecasted graph, you can see there is a decreasing trend in the data. Also, there is a seasonality from October to February. There is a seasonality from October to February. So the same technique used for their significant risk factor also. Here PM 2.5 also one of the risk factor. So for this one, MLP is the best method, and using that method, we forecast for the next 2 years. In this one also, there is a decreasing trend and seasonality in these months, from October to February. PM10 is also one of the risk factors. So for that one, ELM is the best method, and we forecast for the next 2 years. In this one, PM10 is decreasing. So next risk factor is carbon monoxide. So here also we use same technique. For this, triple exponential smoothing forecast better. Therefore, using triple exponential smoothing, we forecast for next 2 years. Carbon monoxide also decreasing. it has a decreasing trend. And in ammonia, Sarima is the best model, and we forecast for next 2 years. According to forecast graph, that ammonia has decreasing trend. Also, there is a seasonality. You can see there's a seasonality. So we get the conclusion. Global warming challenges is the serious problem, and most people are still unaware of global warming cause and its effect. These challenges are not only causing trouble to the human being, but also cause that animal and plants. In this research paper, several innovation applications of statistical procedure are suggested for the analysis of air quality index. This analysis shows that these variables are significant for the air quality index. I already said this PM 2.5 and CO shows positive relation and has larger impact on air quality index in terms of magnitude. This paper successfully handled multicollinearity in the presence of autocorrelation rather than handling them separately. As a result, we get generalized ridge type estimator performs better than all other model under consideration. And we also apply time series techniques. In order to control air pollution, we need to control the emission of its relevant pollutants. Therefore, we forecast the air quality index and their significant risk factors. And we have these are the, we consider these are variable, and this one is the dependent variable, and these are the risk factors. So for that one, we get this best model according to their accuracy measure. On the basis of result obtained from statistical technique to embark upon the air pollution challenges, we advocate the following policy measure for the administrators. The administrator need to establish climate policies aimed at curbing global emission in order to improve the air quality. Importance must be given to the use of alternative energy source such as solar, wind, hydro, geothermal, biomass to avoid the continuous burning of coal, which reduce the production of carbon dioxide, methane, and nitrous oxide. Awareness must be given to use of recycle item to reduce deforestation, and administrator take the initiative such as one student, one tree as taken by UGC. Government should divert their attention to reduce emission of gases from vehicle by giving more privilege to electronic vehicle, and also need to control over the emission of gases from industry. Government need to take project for improving efficiency in the conversion of fuel to electricity, which leads to reduction in the pollution. So I refer these all reference papers. And finally, thank you for this opportunity.
Thank you, Preeti. It's a good presentation, and especially this COVID-19, I'm getting so many phone calls. Who is good in time series analysis? Actually, you have a good scope. Future scope is there, because especially people are predicting for the future. So many. I got so many phone calls. Anybody who is good in this time series analysis. But I have only one small doubt. This sulfur dioxide volume you never included in the multiple regression. Usually, I may be wrong. I may be wrong also. Air pollution means sulfur dioxide volume is what coming in the market. I may be wrong.
We consider,
but still you can tell that answer.
Yeah, I consider sulfur dioxide also, but that is not a significant variable. It may be there is a problem in data also. Sulfur dioxide is not a significant variable. That is why I don't consider further.
Okay. What about the effect of this climatic change on the quality of air? Usually, that is what next step is what we will look at. The climatic change is what we look for it. So, how far this climatic change influences the air pollution?
I can say you can see that air quality index have high in October to February. That is the winter season, right? From October, there is a winter season. This October we mark as a withdrawal of that monsoon in northwestern region, northwestern of India. At that time, wind change its direction from eastern to northwest. So in that case, storm will carry the dust particle from Rajasthan, and in sometimes it may be Pakistan and Afghanistan. So it is the main reason to increase the air quality index. Also, the farm fire. The farm fire is the easiest method to get rid of paddy stubble. According to study, there is a 17 to 26% increase in PM 2.5 from this this farm fire. Also, one of the major sources, this one in winter dust and vehicle pollution. According to IIT Kanpur study, 17% of this air pollution, this PM 2.5 increase because of vehicle pollution. Also, 56% of PM 10 will increase according to this dust in winter. So these are the technique we have.
Good presentation, good topic, because even our former US president himself is very much interested in studying the, very rarely a president tells that I am interested in this topic. So
Thank you.
Good field. Wish you all the best, Preeti. Yeah?
Thank you, sir. Thank you so much.
Yeah. Next is Raju. We welcome Raju Steak. Raju
Thank you, sir. Yes, sir. Present, sir.
Yeah.
Here, sir. Yeah. Share. Yes, my screen is visible, sir.
Yes, visible. Little more visible, more better. Slideshow.
Yeah, I will enlarge. Yes, it is visible, sir.
Yeah, visible.
Yeah, okay. Honorable Chairperson and respected delegates who participated in this conference, very good afternoon. I am Raju Sake, Doctor of Philosophy in Statistics under the supervision of Professor P. Muhammad Akhtar, sir, Department of Statistics, Sri Krishnadevara University, Anantapuram. In this conference, I am presenting one paper. My paper title is Fitting of Gompage Model Between Rainfall and Groundwater Levels by Using Partial Sums Method, a Case Study. Objectives of this paper. The basic objective of this paper is to analyze rainfall and groundwater levels of Anantapuram district and to forecast these variables for the upcoming years and to improve groundwater levels in Anantapuram district. That is my main aim also. Agenda of this paper: abstract, introduction and methodology, and final conclusions. Abstract. Present paper deals with the application of time series model to analyze and predict rainfall and groundwater levels in Anantapuram district based on the data collected from January 2007 to December 2016. Gompage model by using partial sums method for the purpose of analysis. The district is divided into 5 zones or revenue divisions, namely Anantapuram revenue division, Penugonda, Kadir revenue division, Kalyandur revenue division, like that, Dharmavaram revenue division. We have estimated the Gompage model values by using the method of partial sums and compared among them by using the data. The data last 10 decades, last 10 years data. Further, validation of the fitted model identified the best suitable zone. That is the mean square error value of the each zone and forecast on the rainfall and groundwater levels of this district. We also calculated a critical difference test and conclusions are drawn based on the results obtained. And introduction. Earlier, we have worked on this data like that the models on the time series analysis on rainfall and groundwater levels data, modified exponential model by using method of 3 selected time points, Gompage model by using method of 3 selected time points, and finally logistic model by using Hoteling's method, and conclusions are drawn based on the results obtained. That is the earlier we will find out. Now, we proceed to apply another method of Gompage model, that is the Gompage model by using partial sums method for both variables rainfall and groundwater levels. Anantapuram district is classified zonal wise or revenue division wise. This is the classification. Here mandals is there, and groundwater level physiometer points is there. 194 physiometer points is there in Anantapur district totally. In zone 154 and 19 mandals is there, like that. This is the zonal wise partitions. And this is the data from 2007 to 2016 data. And methodology to forecast rainfall and groundwater levels through Gompage model by using method of partial sums for different zones, we consider given as follows. The Gompage model yt is equals to k into a power b, b power t. Here logarithms we will apply, and we will parameter values we will find out b and a and k. If these parameter values you can analyze, and you can enter into the, you can substitute into the Gompage model equation. And that is the average rainfall to fitted the Gompage model. And next one is rainfall. It is finishing, and groundwater levels data we will fit in Gompage model. And validation of the fitted model. This is the validation is the most important of the fitted model, it is suitable or not. Here in this table, actual and estimates values is find out. Estimated values of rainfall, that is YCAP values in Gompage model by using partial sums, like that groundwater levels for estimated values. And we will find out that is the least error from MSC values we will find out. Zonal wise we will comparison is there, and rainfall and groundwater levels. Here zone 1 rainfall is the least MSC value, and groundwater levels is zone 1. Same will happen. And graphically we will analyze these estimated values and observed values diagrams for zonal wise for rainfall and groundwater levels. And further statistical analysis. Now we proceed to analyze the given table. The data is we will given, and ANOVA two-way classification. The null hypothesis we will frame, that is rainfall and groundwater levels, both we will frame. Different years and different zonal wise rainfall and groundwater levels. And ANOVA two-way table for rainfall. Here it is F calculated value we will reject for both, but hues in rows, that is years we will differs hues. And groundwater levels we will analyze. We will at here in the rainfall. Huge errors is there in years. That's why 61 is F calculated value is there. Since F calculated value related to rows, years in rainfall is high, so there is a necessity for a critical difference test. Necessity and need for a critical difference test. How much we will differs for subgrouping various years using the following formula: critical difference test, square root 2 into error mean sum of squares by m into t alpha % level of significance, like that, error degrees of freedom. And critical difference test, year-wise aggregate average rainfall for Gompage model estimates by using method of partial sums. Here years 2007 to 2016, and ranking also we will prefer. And the value is 1% level of significance, CD test value 3.90. We will compare these years. Here we will compare, that is the notation is there. Here above notation indicates that 2016, 15, the pairs is there, 2015, 14, like that. The rainfalls, only 2007 is differ compared to all years. 2007 year average rainfall come under another category, and we will pairs is come one category, like that. These years are ranked based on their respective average rainfall. And acknowledgements, I express heartfelt thanks to the responsible for giving the data for rainfall and groundwater levels, both departments. And finally, I express sincere thanks to Sri Krishnadevara University authorities for providing me the necessary facilities in the department to complete my research work. And this is my publications, 4 papers I will publish for various journals. And finally, one sentence I will tell that: to save water and save the lives, Thank you.
Good presentation, Raju, and even this also having a lot of scope. Last year, I went for this Calicut University. Kumaran sir was the PhD guide of one of the students. He is also working on the same, some similar topic on the groundwater level and the rainfall issue. So we can be in touch with sir also. I have only one doubt: how these parameters were estimated in this model?
Yeah, in this Gompage model, parameters is there. A, I think that once again I will show you. These parameters. The Gompage model y is equals to k into a power b power t. That is the Gompage model equation. We will directly, you cannot apply. So that's why here you can apply logarithms both sides, and y is equals to k plus a b power t. That is the modified exponential curve equation. Actually, here you can a is equals to anti-logarithm, so you can use them, and k also. B formula is given. It is the theoretical approach is there, but I am formula you will put on into my screen. B, A and K formulas. This is the parameters, but it is fitting also there in the time series analysis. This is the advanced models, the modified exponential model, Gompage model, and logistic models. This is the advanced models.
Okay, at least one slide on how the model parameters are estimated. If you are present, it would have more value. And second thing, before it, you were the logistic regression with the hoteling. Can you just show the slide once again? Previous slide, somewhere you were mentioning earlier slides earlier.
And yes, I have not mentioned here in this, but
I have seen the slide. Just show me various models, statistical models, which are logistic regression with the hoteling. What is that? I would like to know about it. Just can you show me that?
Yeah, that is y is equals to.
Show me the slide. Show me the slide. Actually, you take that slide. Actually,
but I have not mentioned the logistic model formula.
Show me the slide. Which slide you presented? Various statistical models.
That is that is I think that. This is the fitting. Yes, this is the last one. That is the in the publication.
The original slide which you are showing, not this publication. Original slide. You take that slide.
I am not. Yes, sorry, sir. I am not presenting the our logistic curve slide in the PPT.
Yeah, but still, you take the slide. I want to see the slide once again.
Yeah. That I am orally explain the curve.
I show the slide.
Slide is not there, sir. Sorry, not to prepare the slide. Logistic hotelings method.
Okay.
But sorry, I will. Yeah. Sorry,
okay, no problem. Okay, take care, Rajesh. Wish you all the best.
Thank you, sir.
Okay.
Thank you, sir. Thank you, sir.
We have next presentation, Vasundhara.
Yes,
Vasundhara is there?
sir. Yes, sir. Good afternoon, sir.
Yeah.
1 second, sir.
Vasundhara, Dr. Vasundhara, I think she's there. Vasundhara?
Yes, ma'am. Yes, ma'am.
Yeah, she's there.
Yeah, she's there. Not responding. Dr. Vasundhara, I think your presentation next.
Yes, ma'am. Yes, ma'am. I'm sharing my screen, ma'am. 1 second, ma'am.
Can you share your slides?
Yes, ma'am.
Vasundhara?
Yes, ma'am. Yes, ma'am. 1 second, ma'am.
Can you share your slides? Yeah. Okay.
Yes, ma'am. I'm doing that.
Can't hear you. I think your audio is also. Just increase the volume.
I'm unable to share, ma'am. 1 second.
What happened? Is there any problem?
Yes, ma'am. I'm presenting, but I'm unable to see.
He
my
can't hear you
desktop.
also. So low voice is also.
Yes, ma'am. I am sharing my screen, but I am unable to see my desktop here. Hello, madam.
I'm unable to see my
ఏది screen share?
Any problem, ma'am? Sharing? Sam, you are there? Sam?
Ma'am, I am
Yeah,
there,
you should
ma'am.
start.
1 second, ma'am. Ma'am, is it visible? My
No.
introduction to data
Yeah,
visualization.
now it's visible.
Tableau. Ma'am, it is
No,
visible.
not
Tableau.
visible.
1 second. Yes, ma'am. Is my screen is visible? Ma'am, introduction to data analytics, data visualization, Tableau.
Yeah, now it's visible.
Yes, ma'am. Yes, ma'am. Good afternoon, sir. Good afternoon, ma'am. Myself, Dr. S. Vasundara, Assistant Professor of Mathematics, G. Narayanama Institute of Technology and Science. So, data has been the buzzword for ages now. Either the data being generated from large scale or the data can be generated.
You're not audible, I think. Can you increase the volume? Yeah.
Yes, ma'am. Yes, ma'am.
Yeah, your voice is very low. Can you just adjust your mic?
Yes. Now, ma'am. Now it is. Yes. Hello, madam.
Yes. Yes.
Okay. Okay. Thank you, ma'am.
The mic, I think you just adjust. Yeah, I can start.
Yeah. So this is my abstract. So the data analytics is the process of examining the data sets in order to draw conclusions about the information they contain, increasingly with the aid of specialized systems. So this is my data abstract. And again, I will go to the direct. See, if you want to see the figure here, this is the figure indicates why Ambani's like business strategy is increasing like exponentially. He is initially as a pump attendee with 300 rupees salary. Now he is the expertise of the award and man of century award, more than 2% GDP, 9% exports, 10% of national revenue, etc. See, this is the data indicates every time we have the data, whether the data can be collected from so many sources. The data can be either in a form of a number or a text or a piece of paper as bits and bytes. Now we have the data worldwide. The data is expected to hit 175 zettabytes by 2025. Now, every day, the 5 million consumers are interacting with data every day. So, by 2025, the number will be 6 billions or 75% of the world population. So, billions of IoT devices connected across the globe, which are expected to create over 90 zettabyte of data in 2024. So, the most fact is here, from all the data what we are collecting from the different sources, 99% of the collected data never gets used or analyzed. So much potential is waste. If you are collecting the data without using for any proper action, there is no use of taking the data. So the data is useless. to an organization unless the data can be extract meaningful insights from the data. Now, our day-to-day life is also interacted with the data only. So the product recommended systems, competitive exam preparation, IoT data, research literature review, customer profiling bank. Now we have the recently COVID-19, the Arogya Setu app. If you want to install in our mobiles, we can have the the people who are in and around the data can be separated like the red zone, orange zone, etc. And this locating of the Vikram landers debris. This is all the data we are collecting until and unless analyzing the data. Like this is the process of methodology of analyzing the data to draw meaningful insight from the data. Now, these are the few applications about the data like personalized marketing, mobile advertising, manufacturing industries, smart data analytics. See, for all this, I'm not going into that. Simply, this is the data analytics, how analyzing with our day to day life. From all the data science, this is the multiple of the mathematics and statistics, computer science, business domain knowledge, advanced analytics, etc. Now, the impact of statistics in data analytics. So, how the impact of statistics? Suppose your data is there, until and unless for the raw data, if you want to add some context, then only the data is having some meaning. Suppose large data is there and we are analyzing the data with using some statistical tools, then it is known as the data mining. So the statistical data analysis methods are simply we are having already have some analysis about the hypothesis testing, classification, regression, and time series analysis. It can be divided into four types of data like descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. This is containing initial we have the data. With the help of the data, just we have the information about the data that is related to descriptive analytics. Using the information, we are moving to the causes about the data, how we are happening this data, their diagnostic analytics. The collaboration of these two, we can go to the predictive analytics and we'll move to the prescriptive analytics. So here I'm not moving more about that. My topic is here visual representation with the help of a software Tableau. So every type of graph is visually represented of data and diagrams plot like bar chart, pie, line chart that shows different types of graphs, trends to relationship between the variables. 1 second, sir. I will share one more screen that is about the Tableau. 1 second, sir. My screen is visible, sir. Sir, my screen is visible.
Yes, it is visible.
Tableau, madam. Tableau. Hello, madam. That screen Tableau is visible. Data visualization Tableau.
No, your presentation is visible.
Okay.
The PPT is visible.
1 second.
Not visible coming.
Yes. I think it's loading.
Now, sir?
Yes.
Data visualization Tableau.
Yes.
Yes, ma'am. Thank you, ma'am. So, initially we need to represent the data like that can be using different types of relations. If it is the relation between two variables, we can apply that is initially like it is a pie chart or bar graph. Different types of attributes are there. With the help of different types of attributes, we are using initially with the help of Excel. Now, apart from that Excel, it is a very good platform for data visualization. So why we need the data visualization? What is the data visualization and why the data is visual important? Suppose we have the data, like raw data is there, and the data can be added some context and making for better decision making until and unless the data is analyzed for better decision making, simply the data is not used at all. Now, apart from this Excel, this is the Tableau software. It gives very good application of visual representation, especially for the people who are under doing this data analysis and business analytics. There we can apply this Tableau interface. Now, what is this Tableau interface? This is the process of simply we are distributing the information through visual renderings. This is the most useful professional skill to develop. The better you can convey your points, usually the better you can leverage the information, etc. Now, the data, suppose the data can be complex or mysterious as we can imagine and require proper tools to extract meaning from it. Such tools can be unable to dig deep into the data so that each can discover the more analysis about the data for better decision making. In this context, this Tableau provides such as a set of tools that equip use to data discover and data visualization and interpret. So the one of the most interesting aspect of Tableau making every day very easy is nothing but see to visualize the data instead of the computer software. Some people are thinking that okay, if you want to visual the data with the help of software means we need a lot of coding skills to visual the better. No, this Tableau software not requires any coding skills. Even a non-analyst can also represent the data with a better decision making. Simply it is an interface. The Tableau interface is looking like this. Whatever the data we are having, the data can be, you can take the data with the help of online data sources, or you can take the data with the help of Excel sheet. Whatever the data we have, simply we can import the data in this Tableau interface. Importing the data in the Tableau interface, automatically it will cleanse the data. The process of data analytics, what data is there, raw data is there. The raw data can be added some context like cleansing the data, then only going for analyzing the data for the better decision making. So in the case of this Tableau interface, once we are importing the data with the help of any of our sources like Excel sheet, you can import the data, or you can import the data with the help of online sources like kaggle.com or using indiamygovernment.com. You can import the data directly in the Tableau interface. Once we are importing the data here, okay, well and good. We are not supposed to do any technical coding or anything. In this interface, the data can be cleansed directly. Suppose by mistake, if we are entering the data instead of one time the data, we are entering one or two data points in more than one time, it will not take the data more than one time. It will cleanse the data automatically. It will clean the data automatically. Once the data is cleaned, you can simply have the cost of like drag and drop only. Actually, here we have columns and rows. Whatever the data we are importing here, rows, so you can simply drag the data, columns you can drag the data. Once we are drag the data in this Tableau interface, automatically in the right side, some visual representations are enabled. Suppose you want to represent the data with the help of a pie chart, data with the help of a box whisker chart, any of the like heat map, whatever the representation we need, depends on the criteria how you are importing the data. The respective visuals are enabled here. Once it is enabled, you can easily represent the data with the help of this Tableau software. And one more thing, this Tableau software is containing like very good features. We have the Tableau containing Tableau Desktop, Tableau Server, Tableau Online, Tableau Reader, as well as Tableau Public. Most of it, suppose we the researchers doing with the help of Tableau Desktop. That is for the made for individual usages. Now the main features of Tableau are, this is the Tableau dashboard, collaboration and sharing, live and in-memory data, data source, robust security, and mobile view. So what is meant by this Tableau dashboard? With the help of this Tableau dashboard, the wholesome view of our data, we are importing to this interface of the Tableau, the wholesome view can be visualized with the help of this Tableau dashboard. Now come to the collaborative and sharing. Suppose we are here doing some visualization with the help of some data. At the same time, in some other place, our friends or colleagues are doing, we can collaboratively visualize the data with the help of this sharing the data online, live and in-memory data. In this Tableau, it ensures that connect the data, both live data sources directly you can have. So presently today we have what is the data, data related to COVID conditions. You can directly take the data and we can visualize. So the data sources can be either you can import the data with the help of Excel sheet, or you can take the data any online with the help of the data. Simply you can have the visualization. For this, I have taken the data, COVID data I have taken, August 18th, I have taken the COVID data from India only, not from the whole over the world. I have taken the COVID data in Indian as on August, and I divided it into 4 attributes. The cases are confirmed, the cases are active, the cases are discharged, and also the cases are active. Now, using this 4 attributes of the data, different states and union territories in India, I have divided into 4 attributes. I don't know, like confirmed cases, active, discharge, and deaths. For all the data, simply I imported in the Tableau software. Once I am importing the data into the Tableau software, immediately it will cleanse the data. And suppose in rows I am taking that active cases, in columns I have taken the death cases, or number of cases are discharged, or number of cases are confirmed. Like that, I have simply we are dragging the data related to whatever the imported in our Tableau interface. Accordingly, it will enables the data looking like different types of whether it is a pie chart or bar chart, histograms or Tableau. This is the main feature. And one more thing here, this Tableau software is we have a free trial version till 14 days. Having any research work and we have collected some data, we need to analyze the data with the help of this Tableau software. Simply we can register with our Gmail account, and 14 days we have a free trial version. Suppose collaboratively we are working with the companies, then we can go for purchasing mode. This is my talk, sir. Thank you, sir. Thank you for giving me this opportunity.
Any questions? Okay, who is the next presentation, madam? Kalaivani, yes.
Hello, yes, sir. Is it audible?
Yeah.
Yeah, okay. Sanya Agrawal. Okay. Kalaivani. After
Yes,
Kalaivani, we'll ask.
Hello.
Yeah, Sanya, next you can do. Kalaivani,
Okay. Yes, ma'am.
After Kalaivani, Sanya will do the presentation.
Sanya.
Okay.
Hello, ma'am.
Kalaivani, yeah. You can share your presentation.
Okay, ma'am.
ఆల్రెడీ షేరింగ్ లో కొంచెం తెలియలేదు, అలాగే ఉంటారు మనుషులు.
Hello, ma'am. Is it ma'am?
No, not yet. Yeah. Just go to present now. Yes.
Yeah, yes, ma'am. One second. Hello, ma'am.
Yes. Yeah. Yeah, it's loading. Yeah.
Okay.
Yeah, that's visible.
Uh,
Yeah, you can start presenting.
Okay. Good afternoon, sir. Good afternoon, ma'am. My topic on data depth approach in fitting linear regression models. Hello.
Yeah, we can see your slide.
Yeah, we can. You can proceed. You can proceed. Yeah.
Okay, ma'am. So data depth approach in fitting linear regression models, and myself Kalaivani, PhD research scholar in Bharatiya University, Coimbatore. So first, my topic, data depth approach in fitting linear regression models. Actually, my topic is based on the robust statistical inference. So robust statistical methods have been developed for many common problems such as estimating location, scale, and regression parameters. So the basic tools used to describe and measure robustness are the breakdown point, the influence function, and the sensitivity curve. In statistics, classical methods rely heavy on assumptions which are often not met in practice. Robust robust statistics seeks to provide methods that emulate classical methods, but which are not unduly affected by outliers or other small departures from model assumptions. So this is my abstract. The data depth approach plays a vital role in regression and multivariate analysis. So regression techniques are widely used for analyzing, modeling multi-factor data. It spans a large ensemble of applicative scenarios in many fields, which includes the emerging field of machine learning. So I have done so many methods in this paper. So that is the classical method and also the robust procedure. So the classical method is the least square, and the robust procedure or LMS and MS estimator, MM estimator, and regression depth median. So this is my introduction. First, the depth of a point related to the data set measures how deep the point lies in the data cloud. So it is the actually depth. So the data depth concept provides center outward ordering. So center outward ordering means usually order statistics order from the smallest sample point to the largest sample point. But while in the depth concept, we are taking the middle value and order it to move towards in all the directions. So this leads to the natural center outward ordering of sample points in multivariate data sets. So basically, any function which provides a reasonable central outward ordering of points in multi-dimensional space can be considered as a data depth. So most depth functions, there are so many depth functions like Mahalanobis depth, projection depth, simplicial depth. There are so many depth functions. The depth functions, all the depth functions are robust and affine invariant, making them well suited for the study of real-life high-dimensional data sets that may contain outliers. So the data depth approach plays a vital role in regression and multivariate analysis. So these are other many depth functions procedures has been developed in the past few decades. So such are half space depth, simplicial volume depth, simplicial depth, regression depth, and projection depth. So the regression depth revolutionized data science, and recently its popularity has grown exponentially. So actually, regression analysis is used to express the relationship between a variable of interest, that is a response variable, and the predictor variable. So the robust regression methods provide an alternative to classical regression model when they fail to fulfill the fundamental assumptions due to nature of the data. We all know that the assumptions of the regression model or the relationship between the x and y variables are linear, errors are normally distributed, homoscedasticity of errors or equal variances around the line, independence of the observations. So when these assumptions are violated, our robust regression methods has better well as compared to the classical regression methods. So these are the regression procedures which I have done in this work. So first is the classical method is least squares, and the robust method is the least median squares method, S estimator, MM estimator, and the regression depth median procedure. First, the regression procedures least square method. So it is we are considering a regression model. Y is equal to beta naught plus beta 1 xi plus epsilon y. So we have to estimate beta naught and beta 1. So this least square method is nothing but minimizing the sum of errors, sum of the squares of errors. So here we are taking the mean. So mean contamination level is 0%, so it will influence the result. But the next method is least median square. It is a robust method, so it can allows the breakdown of 50%. So we are taking the median, so it gives an better result as compared to LS. So next is S estimator. So in least squares, least absolute deviation squares also, and in M estimators, the outlying observations sometimes strongly influence the estimation result. But in the S estimators, that overcome this difficulty by smoothing, by giving the weights, less weight to the outlying observations. So in this S estimators, it gives an better result. So these are the robust procedures. So next, MM estimator is nothing but the combination of the S and the M estimator. So next, the regression depth median. So in this regression depth median, it is a fit. We are taking the median values that allows for skewness and heteroscedasticity distributions. Also, we can use for the regression depth median. So next, the concept is regression depth. So regression depth as a quality measure of robust linear regression. So Russo and Hubert 1999 extended the notion of depth to the linear regression, introducing the regression depth. So in other regression concept, we are taking the residuals. So but in the regression depth provides the rank of any plane or line. So rather than the rank of observations or residuals. So the regression depth is used to find to fit a beta related to a data set Zn is the smallest number of residuals that need to change sign to make beta a non-fit. So always the regression depth lies between 0 and n. So the upper bound is reached if all the x and y lie exactly on the straight line. So this definition has compactable statistical properties such as scale invariant, regression invariant, and invariance under affine transformations. So affine invariant in case that the depth of the point x belongs to R should not depend on the fundamental coordinate system or in particular of the scales of the fundamental measurements. So scale invariance is such that scale invariance is a feature of objects or laws that do not change if scales of length, energy, or any other variables are multiplied by the common factor. Regression invariance is that, so the regression coefficients is added by, that is, we all know that beta is equal to x transpose x. So scaling the explanatory variables, it does not affect the predictor variable. So it is the regression invariant. So for any data set of n points in d dimensions, in linear regression, the dimension is 2. So there exists a hyperplane having regression depth n by d plus 1. So no hyperplane has regression depth more than this n by d plus 1. So any line lying above or below this line is called a non-fit. So hyperplanes with high regression depth compute well in general error models, including the skewed or heteroscedastic error distributions. So the upper and lower bounds of the maximal regression depth states that for any xy distribution h on r square with a density, it holds that. So the maximal regression depth lies between 1 by 3 and 1 by 2. A regression hyperplane is called a non-fit if it can be rotated to horizontal, and we have to count the points the parallel to the x-axis of any of the predictor variables and pause without pausing through any of the data points. So a non-fit is a very poor regression hyperplane, but it is combinatory equivalent to a horizontal hyperplane, which possesses no relationship predictor and response variables. So in such cases, regression depth can provide a measure of a fitted line that best captures the effects due to outliers. So this is the case study. I have taken the data star CYG, which is taken from the R package robust base. So it contains 47 observations it tells the star thickness. So the first variable is logarithmic log temperature, so which is a predictor variable, and the second variable is light intensity, which is a response variable. So the fitted models and the computer regression depth and p-values are presented in the table. So this is the scatter plot. Here, this is the full observations. This is 47 observations are there in star CYG data. So these 4 observations are in this side. So we are fitting the LS, that is least square method, least median square method, and the MM method, and the regression depth median. The least square method only seeing this line, but all other robust fitness are in this line. So it seems that this red line shows the LS fit as compared to other robust procedures. The classical method LS only fitted in the different way. So because in classical method it gives equal weight to all the observations, but in the robust procedures it gives less weight to the outlying observations. So in after removing the outlying observations using distance plot, the classical method turns to robust. That is, this red line comes this line like robust lines. So we can say that the robust method gives reliable results when they have outliers or without outliers. So this is the 47 observations. When removing the observations, we have this scatter plot. So this is the 47 observations. This is the LS fit, that is least square fit. And here, after removing the outliers, it turns to the regression fit. So the regression, the robust procedures are good when they are having the observations having outliers or without outliers. Next. So these are the results. So I have done the intercept, slope, regression depth values, and the p-values. Here the LS method only having the least regression depth value, that is 0.212. So after, so within brackets that are the without outliers, after removing the outliers, we had find the regression depth and p-values. So 0.212 in LS method. So all other regression procedures, it gives 3.4 near to that value. So after removing the outliers, the least square method gives 0.36 value, but the robust procedures all gives near to 3.8 or 0.38 or 0.40. So in the p-value, least square methods only it is rejected, that is 0.001. The observations contain the outliers, but after removing the outliers, the LS method also be accepted. So the p-value is 0.915. But in all other robust procedures, the p-value is accepted, and also after removing the outliers, it is near to 1. So we can say that so the robust procedures are giving the reliable results when they are having outliers or without outliers. So conclusion, the fitted models under various methods and their efficiencies have been studied under the regression depth approach. It is observed that regression depth under robust procedures outperformance over the conventional regression procedure under with and without extreme observations in the data. So it is concluded that the researchers can apply the data depth concept whenever the model fitting is required when the data contains extremes. So these are the references. Thank you, sir.
References once again, just to show me the references.
Yes, sir.
It's okay. It's okay. Any questions? If there's no questions, we'll go for the next presentation. Sanya Agarwal.
Thank you, sir.
Yes, sir.
Agarwal.
Good afternoon, sir.
Yeah.
Sir, is it visible?
Yeah, visible.
Okay. Good afternoon, everyone. My name is Sanya Agarwal, and I'm a research scholar in Department of Statistics, Delhi University. Today, I'm going to present a research paper which is co-authored by Dr. Sangeeta Chakravarti and Professor Gurpreet Grover. And the title is A Study Analyzing the Association of Socioeconomic and Factors on COVID-related Health Outcomes in SAARC Nations. Presentation is divided into these topics. So let's start with a brief introduction to COVID-19. COVID-19 is an infectious disease which has a higher transmission capacity than previous outbreaks such as MERS and SARS. It was first originated in China and was declared a global pandemic by WHO on 11th March 2020. Since no vaccine is available today, countries have taken various measures such as travel ban, complete lockdown, etc. to stop the transmission of virus. Is the association of 8 countries such as Afghanistan, Bangladesh, Bhutan, India, Maldives, Nepal, Pakistan, and Sri Lanka, which comprise of 3% of the world area and is home to 21% of world total population. Since these nations have similar geographical and demographic conditions and have higher prevalence of poverty, comorbidities, and low in healthcare infrastructure, it poses a serious threat on these nations in coping with the pandemic. So this study basically aims to analyze the impact of socio-economic and demographic factors of these 8 nations, such as population, population density, and various comorbidities on COVID-19 related health outcomes, such as case fatality rates, number of cases reported per day, and the number of active cases in each country. So the data on the health outcome variables and the 12 country-specific variables were taken from publicly available data on various websites of WHO, Johns Hopkins, etc. And for modeling the relationship between the case fatality rate and the country-specific variables, panel regression modeling technique was utilized. Negative binomial regression models were utilized to model frequency type health outcomes such as new cases per day and the active cases. And all the results are reported in incident rate ratios, where incident rate ratio equal to 1 means that there is no significant effect of a variable, independent variable on the dependent variable. Panel regression pooling method is utilized for modeling of case fatality rate, where the model is written as YIT is equal to alpha plus beta XIT plus mu IT, where dependent variable are COVID-related health outcome and XIT are the independent variables. And the negative binomial regression is utilized for frequency type data over the Poisson model because higher over-dispersion was observed in our data. So moving on to the results. So data was taken till 31st of August for estimation purposes. So till that day, the situation of the 8 nations is as follows. As we can see that India has witnessed a very dynamic situation of COVID-19 with more than 36 lakh of people were confirmed with COVID-19 and more than 65,000 deaths were taken place in India. Whereas Bhutan has recorded no single death due to COVID-19. These are the crude numbers, but if we take it into the percentages, that is the number of infected population to the total population in each country, we can see that in Maldives, more than 1% of the population was affected with COVID-19, whereas in India, only 0.27% of population was infected. Sri Lanka recorded the least rate of infected cases with 0.01. Similarly, goes for case fatality rate, which is the total number of deaths to the total number of infected cases in each country. Afghanistan showed that more than 3% of the infected people have died in Afghanistan, whereas in Bhutan there are no cases. Pakistan showed a recovery rate of 94.9%, followed by Sri Lanka, whereas Nepal has a recovery rate of 54% only. These results are also can also be verified from the following graph. As we can see from the first graph that Maldives, the infection per capita in Maldives has is much higher than all the remaining 7 countries since May 2020. The results of panel regression analysis for the case fatality dependent variable are as follows. As we can see that comorbidity countries with the higher comorbidities such as higher diabetes prevalence and higher cardiovascular death rate had recorded the higher case fatality rate. There were more deaths in the countries which had the higher diabetes prevalence. These results are in line with the already ongoing understanding about the COVID that patients with the more comorbidities have severe effect of the disease. Another finding is that the countries with a higher number of hospital beds have a lower case fatality rate. This means that there are more healthcare facilities available and patients are getting better treatment for the disease. Another finding is another very interesting finding is the employed people. Countries with a higher number of employed people below poverty line have a lower case fatality rate. So the reason may be the lower testing rate and the poor quality of data collection in these countries as they have limited resources such as Afghanistan. So they're not able to record the data of how many patients are infected, etc. The next finding is that the countries that have that spend higher percentage on their healthcare expenditure to their GDP have increased case fatality rates. It is generally assumed that the countries that spend more on their healthcare facilities should be able to cope up with the disease more. But in our case, in SARC nations, the results are quite the opposite. The reason maybe can be attributed to the fact that SARC nations are predominantly have poorer healthcare infrastructure, and there may be a problem of decision of allocation of resources. That is, more is spent on containment measures and quarantine facilities and procurement of testing kits than on the other facilities. And the final result of this analysis is the life expectancy, that the countries that have more higher life expectancy have the higher case fatality rates. This may be that the older patients with chronic diseases were at a higher risk of severe COVID-19 related health outcomes such as mortality. Hence, those nations are experiencing more fatalities than other nations. Moving on to the results of negative binomial regression for dependent variable of new cases per day, we can see that the Global Health Index, which is GHS, the countries which the Global Health Index of Security is the overall preparedness of the country. It was created in 2019 and it is measured on scale 0 to 100. Where 100 means that the country is completely prepared. So the result shows that countries which were more prepared witnessed more number of new cases per day. Now, this result suggests that no country was majorly prepared against this pandemic. Hence, there is a need for local, regional, and national collaboration to address the gaps in the nations and invest in countries that are far less prepared. Another finding is that the countries with the higher population density and TB prevalence have a higher number of new cases per day. Now, this can be due. This is due to the fact that countries where the SARC nations have a higher TB prevalence, and it is also a communicable disease. So we can see that there are increasing number of cases, and due to proximity and for population density, due to the people living very closer to each other, there is higher chances of transmitting the virus to another in those countries. Another finding is the age dependency ratio. Now, it is a ratio, it is the percentage of dependent population that ranges between that are below 15 years and above 65 of years to the working age population. Now, this result shows that the countries where there are more dependent population have higher number of new cases per day. Uh, uh, the result, this result can be due to the fact that in South Asia there are generally more than 3 generations are living together in a single household, and due to the higher population density and more number of people, there are higher chances of transmitting disease into the families, thus increasing the number of cases. Another major finding of this analysis is that countries that issued higher stringent measures that were more stringent in their measures, such as lockdowns and banning of all social travels, etc., have the new number of new cases. Now, this result suggests that the government response was not very effective in the countries. Uh, this may be because of the high population in the region, and people were less supportive in maintaining social distancing. So there is a need of more innovative ways in collaborating with the population, government population collaboration in minimizing the impact of disease. Moving on to the active cases, that is those cases which are neither recovered, neither are dead from the disease, we see that countries where with the higher cardiovascular death rate and higher population density have the higher number of active cases. And one of the major findings of this analysis is that countries where there were more hand washing facilities available, there were higher number of active cases. Now, this is a very contradictory result, but this result can be attributed to the fact that the higher population density in the SAARC nations makes it difficult to follow the basic hand washing and hygiene regime, thus increasing the transmission and less resolvement of the disease. So finally, concluding the topic, I can say that the comorbidities such as cardiovascular death rates, TB prevalence, and diabetes are associated with increased national caseloads and mortality. High number of hospital beds and health expenditure as a percentage of GDP are associated with reduction in active cases and caseloads. So there should be increase in the number of beds and more should be spent on healthcare. Countries with a higher stringency index witness higher reported new cases per day. So in a nutshell, although SAARC nations are still very less affected by COVID-19 in terms of mortality than the other nations in the world, but its weaker healthcare system poses a threat, and these nations should come together and collaborate and pool their resources in an innovative way to help the population and mitigating the impact of the disease. So these are the references that I have utilized.
Good presentation, Sanya. Panel regression method. What is this panel regression method?
Oh, okay, sir. Sir, panel regression method.
Yeah, can you little bit explain? Not looking at the slide, just orally.
Okay.
Can you just tell what is this panel regression method? What is this IRR which you are mentioning in the panel regression? What is the IRR indicates? The table you are showing.
Yes, sir. Sir, it is the incident rate ratio. We generally it means that how much.
You are talking about the case fatality rate.
Yes,
so just show me that slide again. Just keep that slide. Panel regression. Yeah. Sir,
Yes,
can you case fatality rate is the outcome variable. So
yes, sir.
That means life expectancy, for example, incidence rate ratio of yeah.
Sir, it means that
Can you explain one variable? For example, life expectancy 3.016, incidence rate ratio as 3.016 for case fatality rate. Can you explain what does it indicate? Simple way.
Yes.
Simple. Yeah.
Yes, sir. Sir, it means that countries that have higher life expectancies have higher case fatality rates. When the IRR is greater than 1, it means that the independent variable has more impact on the disease.
What is the meaning of incidence rate ratio? Can you explain what is incidence? Usually we'll came other ratios, but particularly here, what is called incident rate ratio? Can you explain a little bit on that term?
Sorry, sir, I am not able to hear you.
Can you explain what is the meaning of incident rate ratio, IRR?
Sir, it is a rate. It is a rate ratio which says that how an independent variable is affecting the dependent variable. What is the rate of effect uh, of um, of the independent variable on the dependent variable?
Okay. Anyway, but how the variables have been selected? Negative binomial testing, you have separate another selection of variables. Panel regression, you have another way of selection of the variables. Sorry, for a case fatality rate, you have another way of selection of variables. And for the next thing, what is the next thing? Frequency type health outcomes, you have another set of variables.
Actually, sir.
No, the question is how these variables were selected. You have little bit. Can you contribute a little bit how the variables were selected in
Actually,
this study?
sir, I was not able to select all the variables because we have only data on 8 countries and there were 12 independent variables. So I have to limit the number of variables. So forward selection technique was utilized and the R square was checked for which model fitted the best.
Okay. Anyway, wish you all the best. It's a good attempt.
There is a question from Mahesh Deshpande. Same thing, I think. So in the chat box, it is there. From
Mahesh, if you are there, you can orally
but he's
talk now.
written that he doesn't have mic. So his question is that same thing, sir, what you have asked. In negative binomial regression model, how the relevant variables have chosen. And you have taken different regressive variables for different responses. So that's the question.
That's a common feeling which everybody just a first round feeling. That is a feeling which we all feel suddenly when we see the slides. That's what I have asked that thing. Anyway, wish you all the best. Tanya, take care. It's a good presentation. Good presentation, relevant presentation because secondary data analysis is having more value nowadays. So this type of studies are because more internationally they will look this type of papers rather than community surveys. This type of data presentations are more important nowadays. Wish you all the best. Take care.
Thank you, sir.
Yeah.
The next Navajyoti is there. Navajyoti. Otherwise, Abhiram Dash, sir. Abhiram Dash.
Abhiram Dash. Yeah, please.
He's joined this.
Yeah, Abhiram, I'm not seeing your photo in the system. Abhiram.
Yeah, I know he joined just sometime back.
Yeah, I can see it.
So I am going myself, Dr. Abhiram Das. I am working as assistant professor at Odisha University of Agriculture and Technology in agriculture statistics. So I am going to present use of spline regression technique for growth rate estimation of Kharif pulse production in Odisha. So I will be showing the use of this spline regression technique towards regarding the Kharif pulse production in Odisha. So as we all know that the pattern and behavior of agriculture data, it vary in different phases in a long period of time. So to capture this abrupt changes in the data, the spline regression technique can be considered to be very effective technique. Where we can capture these abrupt changes without losing the continuity of the model. We can also fit different models to different parts of the time period, but in doing so, we will lose the continuity of the model. But the spline regression technique will not will ensure the continuity of the model. Now, the present study focuses on use of spline regression technique in estimating the growth rate of area production and yield of Kharif pulses in Odisha. And we have selected the models on basis of this scatter plot of the data. And the data are collected, the secondary data were collected from the Odisha agricultural statistics from 1970-71 to 2017-18. Now, to ensure the effectiveness of spline regression technique, it is compared with the ordinary regression. In ordinary regression technique, the selected models are fitted on the data for the whole period, whereas in case of spline regression technique, the models are fitted for different segments of data without losing the content of the model. And the whole period of study are divided into different segments in such a way that the pattern within a segment remains same and changes abruptly in the consecutive segment. And the scatter diagram method is used for determining the different segments of the entire period. Used the model diagnostic criteria such as Durbin-Watson test, Shapiro-Wilks test, and Brest-Pagan test to test the independency, normality, and heteroscedasticity of the errors respectively. And the model fit statistics such as adjusted R-square and mean absolute percentage error, MAPE, they're used to select the best model. Now this is the scatter diagram where we have splitted the.
I'm not seeing the slides. I'm not seeing the slides properly. Can you just?
Yes. Yeah. Yes, sir. Yes, sir. This is the scatter diagram where we got the 4 periods. Basing on the study of this scatter diagram, we got the we find that the entire period can be divided into 4 different segments. At the period 1, period 2, 3, and 4. This is for the area under Kharif pulses. And here we find that there is a change in after 1981-82. Then within this period from 82-83 to 95-96, there is a gradual the data vary, but there is also an abrupt change in 1995-96. So the third period is considered to be 1996-97 to 2002-03, and the fourth period is 2003-04 to 2017-18. Similarly, we have done this for yield of Kharif pulses also, of the 4 periods, for the yield of the Kharif pulses. Then we have also done it for the production of Kharif pulses. But in production, we find that the past period is from 70-71 to 1980-81, which is slightly different from the area and yield. Then, basing on the scatter plot of the variables under study, the models which are found suitable for estimating the growth rate are linear, compound, and logarithmic models fitted under ordinary regression and also using the spline regression technique. And the knots, that is the breakpoints, they are placed in the data by using the scatter plot. In case of area and yield of Kharif pulses in Odisha, the whole period of 48 years, that is from 70-71 to 2017-18, the knots are placed at the year 1981-82 first knot, 1995-96 second knot, 2002-03 third knot, which correspond to the time period to t equal 12, 26, and 33 respectively. So thus these are referred to as K1, K2, and K3 respectively. In case of a production, the whole period is divided also into 4 parts, but the first knot is placed at the year 1980-81. And second knot same as in case of area and yield, 1995-96. And the third knot is at 2004-05.
Abhiram,
So which time period?
Again, I am saying that
11, 24, 35.
The number of content in a page is too high because in a slide, maximum 3 or 4, 5 lines, it should not exceed more than that. So we are not able to understand fully what you are telling. Can you just summarize important findings and important record? Because it's an international conference. It's not that we can't read the whole paper from top to bottom.
Okay.
Nobody will be able to. Even I am not able to. Nobody can understand. So the 10 minutes time, what we expect is you like other presentation. You must have seen it. Can you just tell you come prepared with some important take-home messages, new methodology which you have done it. Highlight those things. That is which one expect from you. But if you can you just simplify what you have been doing? Okay, that will be more easy for us to understand what you are doing, because only 10 minutes time is allotted for you.
Okay. So see here I've used these models, the ordinary regression models, and also these are the spline regression models. These are the spline regression models: linear spline model, and compound spline model, and logarithmic spline model. Here we have used 3 knots for this model, and we have got the coefficient values by using the ordinary least square techniques, and the significance of the coefficients of the model are also tested, and the overall testing of the model is done by applying the F test. And the final conclusion is that it is found that from the study that the spline regression models perform better than ordinary regression model, both on basis of model diagnostic criteria and model fit statistics. And the spline models found to be best fit for which are found to be best fit for area and production. They are respective linear spline models, and for yield the logarithmic spline model. And the growth rates for the study variables are found for the whole period as well as for the different segments of the study period by using the fitted values obtained from the best fit model. And this is the table for the growth rate. Here for area under Kharif pulses in Odisha, in the period 1 it is 7.08 and period 2 6.34, whereas in period 3 it is the negative growth rate found to be negative -6.04, and period 4 it is insignificant, and this gives for the whole period a 3.6% growth period, which is growth rate which is significant at 5% level. Similarly for yield also, in first period the growth rate is insignificant, for second period it is positive and significant at 5%, for the third it is negative, and for fourth also it is positive significant, but as a whole for the whole period it is found to be insignificant. Whereas for the production of Kharif pulses in the first and second period they are highly significant and positive and highly significant. Then in the third period it is also significantly negative, but I have done a mistake. I have not put the double star, so it is also significantly negative. And in the fourth period it is significantly positive, which gives rise to the whole period it is significantly positive. So these are my findings. In this study I mainly compared the ordinary regression model with the spline regression model, and I found that the spline regression models, they perform much better than the ordinary regression model when the time period is quite large.
Thank you, Abhiram. The content is good, but only thing, the presentation can be little more improved. I just tell you how it can be improved.
Yes.
First thing, first slide, I expect you to write what is this spline regression technique. What is that? Second thing, second slide, I expect you to write what made you to think that spline regression technique are relatively fit better than the other so-called regression. What was the rationale of you to think like that way? And third thing, third slide or fourth slide, some of your databases which you have been taking. And fifth slide, I expect you how you fit the models and what made you to how you conclusion were arrived it. And sixth slide or seventh slide, if you can tell the conclusion for it, the whole presentation would have been little more impressed or impressive. Anyway, you are all very youngsters. This is my humble advice only. So take care, do a better content is very good. I appreciate the content of the study, but the presentation can little more improve it. Wish you all the best, sir. All the best wishes, Abhiram. Okay.
Thank you, sir.
Yeah. Now next is
yes,
yeah.
Shobha Rajmanya. SV Rajmanya. She's Shobha.
Yeah.
Shobha Raj. Yeah.
Okay, I'll share
your presentation.
Yes. Oh. So why it is not present?
Go to present. Present now.
Yes, I am presenting. Yes, yes. But screen is not sharing. Open the file.
First open your file which is to be
So
presented.
you should keep your PowerPoint presentation
Present.
ready.
Open first.
Yeah,
Okay.
and then select it.
That's it.
Okay, sir.
No, what you have done is correct, but now you have to choose the PowerPoint presentation.
Okay.
ಸರ್ ವಿಷ್ಣು ಸರ್ அவங்க ಸಿಸ್ಟಮ್ ஏதோ ப்ராப்ளம் சார் ஜஸ்ட் லீவ் பண்ணிட்டு திரும்ப
Can you
ரீஜாயின் பண்ண
send your present?
எஸ் மேம்
அவங்க அனுப்ப சொல்லலாமா? அவங்க
எஸ் மேம் கிருத்திகா மேம் எஸ் மேம்
Shobha,
now
can you
now
send
she
your
said join and just a minute ma'am ஷோபா
ஹிசாம் இருக்காங்க? ஹிசாம்
நான் இப்போ ஜஸ்ட் வெளியே போனாங்க இங்க தான்
Okay.
Shobha, can you hear us?
I cannot see my screen, sir. I don't know.
You just now you are logged in which browser?
Yes, sir.
You are logged in which browser? You are using which browser? Chrome or Mozilla?
Google. Google.
You use Chrome,
Chrome, right?
Chrome browser.
Yes, sir. So
now they are showing that left side present now is right, right? Hello?
Share.
You just click the present now.
Yes, yes. I press the present.
Now you are sharing. You want to share your PPT or
yes,
PDF?
Sure. But it's not opening.
Just wait.
Yes.
Just wait. Now you just go to that PPT.
But my screen is not.
No. Your screen is shared.
Okay.
You want your presentation in PPT or PDF? PPT, right? You just go
PPT,
and select. Open your PPT.
Okay, sir. Okay.
You just yes, that one. PPT.
Yes,
Yeah, you do that, madam. You select
Yes.
that. Yeah.
Yes.
Yeah,
It is visible now.
Thank you,
Now
sir.
it is visible. And now place this in a slideshow.
Slideshow, yeah. You click slideshow.
You keep an full screen.
Next, little right side. Right side you have to come. One more, right side, madam. To your right, you have to come.
Yeah, that one.
That one.
Thank you, sir.
Yeah. Just proceed.
Okay. So today's my presentation is on control chart, Kusum control chart using regression type estimate using auxiliary variable. I am from Sangameshwar College, Solapur, Maharashtra, and this is my plan of presentation. So usually we Short's control chart of R for process variability R and S. But here we do some memory-based chart, which is known as cumulative sum Kusum control chart. It's memory-based control chart. It utilizes the past information in setting up the control structure. We know for a Short's control chart, the decision is based only on the last point. The previous all points we do not consider, ignore. But here we use all the information, previous information. That is, it is known as memory-based control chart. I have used regression estimator. That is, instead of only using one variable, some other always. So one of the variable I have taken as auxiliary, and using this variable, I prepared the chart, which is known as Kusum chart. This is just introduction, what I told just now. Review of literature. Many Kusum charts I studied and then I tried for this. This is the usual traditional R and S chart. Then we know that these charts are for large shifts, effective for large shift, but less effective for small shifts. And because of only recent observation, depends only recent observation. Then I'll explain about this regression, auxiliary information, and then regression estimator. So X, Y bivariate data I have taken. Then this is a correlation between this variable independent variable Y and auxiliary. Then this is defined a regression estimator. VR is SY square plus B. This like this defined using sample information, and X is the auxiliary variable. Kusum, we consider all this previous points. We consider all this memory of all these points. Then this is the design of Kusum chart. We calculate that is the statistic for each sample, and then using this format we calculate the statistic WT, where this K is the reference value. The chart signals at the first sampling range such that W2 greater than H, where H is the decision interval. The process is considered as out of control when WT greater than H. Simulation study is used for getting ARL values. The values of H are obtained by designing the chart to have an in control ARL of 200, and then we compared it with Kusum R and Kusum S chart and the usual Schwartz VR chart. So this is my table observations. So this is a Schwartz VR chart, and for different correlation we prepared the records. All this, the original ARL value is simulated to 200, and then by giving shifts we got these values. Then Kusum R and Kusum S charts for n is equal to 10. Sample size is taken as 10, and this is our values for different correlation 0.3, 0.6, and 0.9. And we got this result for small shifts. If we compare with shorts, we can get that these values are very effective, smaller than the shorts value. So we can detect the out of control very easy earlier. And for comparing to shorts VR chart and comparing to Kusum charts R and S, we got the values better for correlation is greater, that is 0.9. The values are better comparing to Kusum R and Kusum S. So these are the observations for n is equal to 10, and the same of the calculation I have done for n is equal to 15. And here we observe that of course for shorts VR chart all values are consistently better, and even for large sample, that is when n is equal to 15, for all correlated values from comparing with Kusum R and Kusum S, the values are much better, consistently better than Kusum R and Kusum S. So this chart works for large sample size better than small sample size, we can say. So we can just compare the values from VR chart. These are always better, and from Kusum R and Kusum S, the values are also better. Means smaller the values, the chart is better. Smaller the ARL values, the small values are So from this table, we can say that it can be interpreted for large sample. The Kusum VR chart is performing better than Kusum S chart, and also better than Schwartz chart. So total conclusion, we can say that chart based on regression estimator using auxiliary information is developed for monitoring process variability for normally distributed process. From the above discussion, we can observe that Kusum VR chart is giving good performance than VR chart, Kusum R, Kusum S with increase in correlation between main characteristics and auxiliary variable. And with increase in sample size, we can observe that Kusum VR chart is uniformly better than both Kusum charts for small to moderate shifts in process deviation. So this emphasizes the robustness of Kusum VR chart. These are some references I have used for proposing this chart. Thank you, sir.
Good presentation. Good presentation.
Thank you.
Any questions? If there's no question, we'll go for the next presentation. Gajula Health Insurance Claims in India. Presentation by.
Sir, I think Gajula and Harsh Tripathi are not there. They have not joined.
Okay.
Yeah, I think
so,
Sriman Narayan Gajula, Harsh Tripathi. I think both of them not. Okay.
So then we can conclude.
Yes, sir. Yes.
So anyway, thank you, madam,
Thank you,
for giving me this opportunity to chair this session.
Thank you,
All the presentations are good. Even if we make some comments, keep the criticism positively. It is for your improvement only. So hope you will take this criticism positively, and wish you all the best of luck. And once again, thank you, Dr. Naveen sir. Also, thank you, sir, for inviting me. Thank you, sir.
Thank you, sir. Thank you very much for accepting to chair this session.
Again,
I also thank.
Don't go away. I will be giving an invited talk today.
Yes, sir. Yes, sir. I know next session we have, sir, and I also thank all the participants who have presented.
Don't go away. You can have a small half-an-hour coffee break and can come back.
Yes, sir. Yes.
Yeah.
So next session will start at 5:30. We have an invited session. You all joined with the Google link, which is the morning, whatever Google link was sent you, that link you have to join. Okay. We will have a break now and we'll all join back at 5:30 for the invited talk. Please. Thank you. Thank you.
Thank you.
Naveen sir, anything? Naveen sir, you would like to comment anything? Vishnuvardhan sir?
No, sir. Just I'm listening. Yeah.
Thank you, sir. Thank you, sir.
We'll listen to your talk in next thing.
Thank you. Now we can all leave the meeting and we can join the next session at 5:30.